Hey everyone, welcome to the Fargo 3D Printing Podcast. Today we're going to talk about Freedom USA. So last week we had Dan Sawyer in talking about Ingeo and NatureWorks, so it was great having him on the podcast. If you haven't seen it, go check it out. He talks a lot about sustainability, where PLA came from, where NatureWorks came from, and kind of how all the PLA kind of happened. And then the week before we didn't have a podcast, but we released a Rep 2X heater block video, so go check that out if you have a Replicator 2X. This is a replacement for your hot end.
Heater block.
Sorry.
Not the whole hot end.
Not the whole hot end. But for the heater block, it's a silicone instead of a ceramic. So it'll last a lot longer and it won't break. So today what we're going to talk about is Freedom USA. So last week we launched Freedom USA, which is a spin-out company that we have, and we manufacture high quality 3D printer filaments. So we have PLA and ABS. We're going to get into some other materials coming in the next couple months. We'll have some really cool announcements about that. But what's so important about our filament? Well, there's a couple different things. Quality. So when we talk about quality, we talk about tolerances, and we talk about the consistency of those tolerances, as well as where the material actually comes from. We use Ingeo PLA from NatureWorks. We're the only one preferred vendor from NatureWorks in both Europe and here in the United States for PLA. So that's they don't just hand that out. That's why we have the Ingeo branding, and why we're able to use that.
So a little background on that.
Yeah.
We're the only, like Jake mentioned, we're the only independent filament manufacturer in North America that has the Ingeo distinction. And we're not necessarily the only ones that use PLA from NatureWorks, but we're the only one that NatureWorks has recognized. They've gone in, seen our manufacturing process, and Ingeo is their stamp of approval, saying, hey, this is someone that we recognize makes filament really well. It's consistent, good quality filament, and the manufacturing process is sustainable. I mean, that's Ingeo's big thing. Again, NatureWorks isn't the only company that makes PLA, but they're the only ones that make it as sustainably as they do.
And at commercial levels, I believe.
Yeah. Well, yeah. So they're the only ones that really publish how sustainable their PLA is, and that's a big deal. I mean, they had an independent study done, very sustainable, low carbon footprint, very low use of non-renewable energy sources. So that Ingeo is very unique in that.
And we bring that in too with our vision and goal, because we have an Eco-Spool, so it's 100% bio-based spool. It actually is a mixture of PLA and a couple other compounds.
Yeah. So one of the materials in the spool.
Yeah.
So PLA, generally it's basically plants sequester greenhouse gases and basically turns greenhouse gases into plants, and then plant-based sugars get turned into lactic acid. Lactic acid gets turned into PLA, polylactic acid. So we have that plant-based plastic in the spool, but then there's also another material, and it's actually something. It's an agricultural waste product. So it's something that normally would have just been tilled back into a field or would have just been left out or thrown away.
It's not used at all.
Yeah, not used at all. So we're being able to make the spools from more plant-based materials. And the cool thing about it being bio-based is it will eventually break down. Now, it might not break down in a typical landfill setting, because in a landfill, this is something that we learned in this whole process.
Anaerobic.
Yep, anaerobic. So basically,
there is no air. Anaerobic means there's no air.
So basically, the
process.
landfill, they end up sealing it up, take all the, they don't add any moisture to it. They try and take take as much air out of it as possible, so it doesn't break down like industrial compost would. So you put the spool in an industrial compost situation, high heat, high humidity, the spool will break down.
In about I think like a month or something like that.
It's about 1 to 3 months, depending on the
how much
on the temperature.
Food they're giving it with that moisture and humidity.
Exactly. So that's something to keep in mind with the spool. It's not necessarily going to take up less room in a landfill. I mean, if you open up a landfill from 40 years ago, you can still see, if you look at a carrot, the outside will be brown, but the inside will still be orange. And that's just how the landfills work. But the fact that this is made from plant-based materials instead of petroleum-based materials like so many other spools, it really just helps it be more eco-friendly.
And the nice thing about this is, so we're taking resources here in North Dakota. The compounding company takes that agricultural waste and makes it into this plastic here in North Dakota. Their plants north of town, we send it to an injection molder that I can actually throw a stone at their building pretty much, and it comes to us. So we're very eco-friendly in the regards of sustainability on the whole transportation side. It's everything is very close to us, so that there's low carbon footprint with this, with the Eco-Spool. So that's kind of the sustainability side. I don't know if you have anything more to add on that.
No, I mean, on the sustainability side, that's the big thing.
And I guess our boxes are actually from recycled cardboard as well.
Yeah.
So that's another thing that we have done. So with kind of the other goal is building better. So when we say build better, you look at your parts, and if you go to a Chinese manufacturer or an overseas manufacturer, just some really garbage filament, it doesn't always build the best. It breaks apart, the layers don't adhere, you have extruding issues, where our stuff, because of its quality, you can build better. So
now so a lot of imported filaments, and not China specifically, just there's a lot of overseas manufacturers that they are able to make stuff very inexpensively. But the way that they're able to make those materials inexpensively, they don't have as much care in the manufacturing process. They use filler materials, or they're just using really poor quality materials to begin with. On the filler materials, that's one of the big things. If you've ever bought like a $20 spool of material, if you buy from three or four different sources, even the texture of the filament will be different. And you'll notice that some of it might have different types of plastic mixed in with it. The reason that that's a problem is if you don't have, or even if you have the same type of plastic but it's multiple grades, those multiple grades have different melting points.
Yeah.
So think of it as, what's a good example? Let's say you have Jell-O that has M&Ms mixed in with it. Still really, I know it's a weird analogy.
Don't worry, I'm trying to...
It's a weird analogy, but you'll understand where I'm coming from in a little bit. So imagine it's a big sugary mass. So yeah, it's sweet. So you're like, okay, well, it's sugar. But the thing is, Jell-O melts at a different point than M&Ms melt. Now, if you're trying to squeeze this through a small opening, okay, you have all the Jell-O melting just fine, but now all the M&Ms are getting bunched up because they're not melting as quickly. So now you have all these M&Ms that are jamming up the nozzle. So think of that as the filament. You have one grade of plastic that has a lower melting point than another grade of plastic. So the first grade with the lower melting point melts first, extrudes no problem, but that second grade, at first it's not an issue because it just sort of goes out with the first grade, but it starts bunching up, and then you have an extruder clog.
Yeah. And it's kind of tough to tell what fillers they're using, because it's, they might be, or what percentage really is it 80% polypropylene and 20% PLA.
That's a ridiculous ratio.
You never know, because that's what you never know what you put in there. We actually have, and this talks to two different things. We have a spool of filament in here that we got from overseas. I don't know how many months ago, but we got it in. We left it in the vacuum seal bag, but we actually put it onto one of our earlier Eco-Spools. We just wound it on there to see what it looked like. Well, the plastic, two things. One, the plastic was bad, and B, the internet
mixed identifiers. One, this was this problem. B, here's the second part of the problem.
Well, they're still following.
If you're listening to this, I have problems with that. So
I don't count very well.
Doing algebra, you're counting with algebra. You got letters and numbers mixed in there.
My algebra teacher would be very happy with me that I'm mixing numbers and letters together. Isn't that what we were taught in high school? Anyway, so the first thing is the material was a bad grade, and the second thing, there you go. The second thing is the spool diameter. So if you look at our spool actual diameter where it's wound onto is about 3 inches across. So what that allows is so that when the filament goes on there and we're winding it, it actually doesn't that memory of the spool doesn't cause it when it's unspooling to break and kink. So we actually have a filament in here that we respooled onto another spool, and it actually exploded after, I don't know, about a week or two.
Because there was so much stress. Tension. There was so much stress on the material, because when it, like Jake was saying, when it was spooled on, instead of having a core diameter, hit the mic. Instead of having a core diameter like this, it had a core diameter about half the size of this inner part. So it was wound. So it was wound very, very tightly. Now, when it's wound that tightly, it has a very hard time unspooling if you're just spooling it off of there. And then when we took it from that smaller, tightly wound spool, and we put it on ours that had a larger core diameter, like Jake said, it really
literally exploded.
It overly stressed that. And so that's another. I guess that's another thing back with the Eco-Spool
is
Yeah, so there's that. And then one more thing that we haven't brought up on the spool is how well it's wound. So this is a 1.75 millimeter spool. On a 3 millimeter spool, it's very evenly wound, so you don't need to worry about filament crossover. So if you have crossover when the spool is being unwound, it basically leads to a filament tangle. So where it's actually tangled on the spool, and then your extruder can't pull it, and then your print fails because you start air printing. So that's just one side of the quality. The other side is when we start getting into diameter and ovality. Mm-hmm. So diameter, this is a pretty big deal because diameter, you want it to stay consistent all throughout the entire spool. If your diameter is changing too much, well, you're telling your printer that you're going with diameter A, but if all of a sudden it changes to diameter B, which is larger, it's the printer
there's more volume.
The printer's not going to change how fast it's pushing filament through, and by fast I mean length.
Yeah.
So it's going to push the same length of filament through, but the volume is going to be different.
Because there's an algorithm in the software that says, all right, I know 1.75 is 1.75, so I know that I need to push this, and within an inch there's this much volume, so I need to push this fast to push out this plastic, and there's that algorithm in the software to figure that out. So like John said, if there's a different size variance, it's not going to know that, and it's either going to over extrude or under extrude based on the diameter. That's just one of the things.
Yeah, so diameter is a big deal. Ours is extremely consistent. We say our tolerances are plus or minus 0.05 millimeters. With PLA in particular, it's actually closer to plus or minus 0.02, 0.025 millimeter variance. And then ovality.
Well, hold on, back up to diameter. So the other thing that can happen with the diameter fluctuation, not only is it over extruding or under extruding, but it can actually jam up in the thermal barrier tube. So if you look at a thermal barrier tube, it's steel. There's no way a hot plastic's going to push steel.
Well,
so
some have a PTFE liner.
Some do, but
a lot are steel.
But if you look at that, what's going to happen is when it if there's too wide of plastic, it can actually get jammed up and stick to the sides of the walls. And then with the heat creep issue, if it sticks too far up, it's never going to melt again. So then it starts to pretty much get a clog, kind of like an artery, and it clogs off and you can't get anything through. So that's another thing with diameter, is that it can actually, if it gets too big, it can stick to the walls and cause extruder jams.
And in that case, you either need to replace the thermal barrier tube or you need to drill out the thermal barrier tube. And drilling out a thermal barrier tube is doable, but unless you have a nice bit, you start running into scratching up the inside of the thermal barrier tube, which will hook onto a filament when you're doing that again.
Well, and they're at a set diameter. So, and some have the PTFE liner, like you said. So if you drill that out and you're like, oh, this is an eighth of an inch, it's exaggerated, but it's an eighth of an inch. Well, it might have a PTF liner in there that's a little bit smaller that you don't see, and you could all of a sudden just ruin that. And then now you're having more issues than if you would have just replaced the barrier tube.
So all of a sudden, your $20 spool ends up costing you more like $40, $50, $60 both, and that's only if you're accounting for the parts and the fact that you need that the stuff that you've already printed is scrap and you have a half finished part. Now you need to go back, print it again, but that's not accounting for your time, both the time that you've wasted already printing a part that you've now had to scrap, and your time having to clear the jam, unclog the printer, replace parts.
And think about engineers when they're billing out at on the low end $100, and they have to spend 2 hours trying to fix something or 2 hours restarting something, total time of a project. That's a lot of money down the drain for him, income wise, where if you would have spent the extra $20 on a spool filament that actually works, then you would have known that it was going to actually print properly and you wouldn't lose your time and you wouldn't have to buy more material of that $20 spool.
Another thing is if you're a 3D printing service bureau and you've told your customer this will be done in 2 days, if you get, let's say it's a larger print and
it's a 28-hour print
and it fails halfway through, okay, if it's a 28-hour print, it's going to take 28 hours to print no matter what. But if you fail 14 hours into it, okay, you're now at 32, 42 hours from the scrapped print to the final print, and if you only had 48 hours to finish it, it's causing you a lot of stress. Or if it fails multiple times, now you've blown your deadline. You're not going to have a happy customer, and you've gone through that much material. If it's a 28-hour print, that's a lot of material. I mean, that's like a full spool of material.
Yeah.
So now you have.
We're going to print a giant Marvin. Yeah. We're in the process of printing a giant Marvin. I don't even know how
Yeah,
much.
it's the 3D Hubs Marvin keychain. So if you haven't seen that
Size of a
before,
basketball.
yeah, it's probably the most.
We'll put a picture up when we get it out.
It's probably the most 3D printed object out there right now because it's a. Well, anyway,
Yeah.
if you have to burn through that much material before you get a finished part, you're really not saving any on the filament.
No, you're losing money all over with your time. You're ordering more of that $20 filament. And all of a sudden, when you order more of that $20 filament, now you got to take that again because it's probably going to jam up and it's going to waste more time. So with the higher quality stuff, yes, it costs a little bit more, but it's worth it in the end, time-wise and printing-wise.
So we talked about diameter.
Yes.
Now we're going to talk about ovality. So ovality is how round the filament is. So if you have high ovality,
This is round.
so if you have high ovality, it means that your x-axis diameter and your y-axis diameter are very different from each other. It means that your filament is more egg-shaped than it is round. If you have very low ovality or really tight ovality tolerances, that means it's very round. So ideally, you want to have ovality of less than 0.01 millimeters. In most cases, we are around, I'd say, less than 0.005 millimeters.
Yep.
So extremely round filament. So if you have filament that's egg-shaped, it might get jammed up in your extruder because even though the average diameter is going to be the same, so your average diameter might be 1.75 millimeters, but your ovality, if it's let's say 0.2, it means that your actual diameter in one axis is going to be like 1.85. It's going to be
really off.
Yeah, so you might even have problems as severe as jamming up in your filament guide tube, which isn't good. And then you also have a more difficult time driving it using the drive, using the drive gear in your printer, because if you have a tensioner that's set for a specific distance, okay, now it's not going to be holding the filament against the drive gear properly. So those are both two big things, diameter and ovality. And one of the things that we do with our filament that's different from everyone else is we actually have the specs for diameter and ovality right on the spool box. So it does look a little technical. It's not very sexy looking, but the specs are very accurate. We use a laser scanner, scans about 400 times per second, and for each spool it spits out the average ovality, spits out the average diameter for that spool, and then there's also a strip chart. So it'll show you how the diameter may have been varying on the spool. And one thing to pay attention to is the upper and the lower limits on that strip chart. The upper limit is plus 0.05 millimeters. The lower limit is minus 0.05 millimeters. And so we get up really close to that diameter, and you can see that it varies very little.
Yeah.
So
it's
very tight
it's very
tolerances.
consistent to 1.75 because this is actually, the mean diameter is 1.752. The ovality is 0.01.
Yeah.
So we're very, very tight in our tolerances. Yeah. So that's the nice thing is every single time you buy a spool filament that you know what the tolerances are, and we're not just saying we're within those tolerances, we're showing you so that you can feel confident when you print. The other neat thing about our quality side for internal use is we can actually, through a couple different things, we can actually track a lot of different things in our trade secret manufacturing process, so that if there is ever an issue, we can actually go back and make sure that everything is correct, there wasn't any issues with it, and so there's a way we can track that on our end.
So we have a batching system. Let's say somehow there is a bad spool that gets out. Then we can go back and track and see, okay, what was going on that day? Did someone just miss a spool? And we haven't had any issues yet.
Was it the new guy?
But having that system in place ensures that we'll always have good quality filament. So another thing is we do have a mascot for 3DEM USA. So this is, well, we don't have a name for him yet.
That's what we're looking for you for. To you for.
We do. Words, Jake.
I'm
words.
Tired. We're recording this in the morning. We usually don't do this in the morning. We do this in the evening when I'm a little bit more awake.
So this is our mascot. Right now we're just calling him Rabbit. We would love some naming suggestions for this. We don't really want to call him Roger Rabbit, just because I have a feeling that might be trademarked.
Yeah, I think we might get a nice cease and desist letter for that.
But a nice looking rabbit like this needs to have a nice name. So our rabbit will be guiding you through how to take care of your filament. He's going to be on, in every spool, we're going to have a little how to take care of your filament packet. So for example, all of the spools come in a vacuum sealed bag, and it's a resealable bag with a packet of desiccant in it. So one example is, hey, make sure that you store your filament in the sealed bag with the desiccant in it to make sure that the moisture level stays down. So, just helping guide you through stuff like that. And if you can come up with the name that we choose for the rabbit, we'll send you one free spool of filament in the material of your choice and color of your choice.
Yeah. So, and the neat thing about color, so put those in the comments below. I think we'll be on our Facebook page, Twitter page. We'll be gathering those over the next couple weeks, and probably announcing sometime later in June. But the cool thing that we do as well is we have what's called transition spool. So when we're switching from, in this case, a red filament to a yellow filament, we actually spool that transition. So we actually have these transition spools. They're a gradient from our strawberry red to our daffodil yellow, and it's kind of a grab bag when you order them. You're not really sure what we're gonna get or what you're gonna get as far as color goes, but you just denote your material type and your size, and then we'll send one out. So they're really kind of fun because we have a couple. I think this one was actually printed with a transition spool. No, was it? No, that was that green color.
That was in springtime green.
We have so we have a couple somewhere, and sometimes there's a really quick change. Sometimes there's a little bit of a longer change. But you get some really neat colors. Like this one, you get kind of a lemonade in the middle kind of color.
Yeah, like a strawberry lemonade.
Yeah, so
or pink lemonade, I guess.
Yeah, so I mean that's another cool thing that we have. Those are up on the 3DEM USA website.
Yeah, so if you want to learn more about the filament, learn about the different materials as we come out with them. For example, we have a couple of new materials that we can't talk about yet.
Not yet.
But
soon.
In about the next 3 to 4 weeks, you're going to be hearing about them. But definitely go to the 3DEM USA website. So that's 3DOMUSA.com. When you're there, if you want to sign up for the newsletter to find out when the new materials come out, that's going to be a good one. Or that's going to be a really good way to do that. Or hit us up on the social media pages, Twitter, Facebook, Google Plus are the three that we're on right now. Eventually, we will have YouTube and some of the other ones like Instagram. But yeah, go to the website, learn more about the filament. If you have any questions, definitely either leave them in the comments below or send us an email.
Yeah, and if you're looking to be a reseller out there, contact us. I know that's in the About Us page. So get in touch with us. We'd love to have a conversation and chat with you.
Yeah, definitely. So on behalf of Jake Clark and myself, John Schneider, thanks for watching the Fargo 3D Printing Show podcast. If you haven't already, subscribe to us on YouTube or subscribe to us on iTunes. Check us out on social media.
Hit the red subscribe button.
Yeah, you're going to be one of those.
I am.
Yeah.
So we don't have a bar anywhere that we can point to.
But listen to Jake, hit the red subscribe button, and we'll see you next week.
See you later. Is your Reddit turned down?
Yeah, my Reddit's turned down. But for what?
For the podcast. For what? Obviously the podcast.
Okay. All right.